So, our next presenter, wow, what a pleasure it is to have him here. And wow, talk about someone who gives back to the community. I think I became aware of Mike before Slack, if anyone can remember a time before Slack, on IRC. I was very active, and a bunch of other people were real active on IRC. And this handle shows up, frogor, and he's answering all the questions and has all the knowledge. And I said, who the heck is this guy? Like, knows what he's doing. And I forget how we actually met and ran into each other. Did I just invite you here one time, or we met somewhere else? If I don't remember.
Actually, I think the very first place we met was at a MacTech conference.
Maybe.
Like the first one I actually just went and
attended.
Yeah.
Yeah. Okay. Maybe.
Yeah.
But you know, we talk about the Apple people that have gone to Apple and now been released, and we're happy to have them back in our community. We're happy you haven't gone to Apple. We're happy you can remain a part of the community through all the places you've been at. The one thing you are absolutely known for is your magic with Python and wrapping in C functions and Objective-C. So I'm going to let you get right to that. Please welcome Michael Lynn.
Thanks. Yeah, I'm, as mentioned, Mike Lynn. Really happy actually to be able to give this talk because as much as I do a lot of work with Python and pyobjc, it's like my favorite hobby pastime thing, which just happens to actually be super functional and useful for work. It also, I've never technically given a talk on it. I gave a very short talk at another conference, like a lightning talk or whatever, just to try and like get people interested in it. But I've never actually like gone into depth on like functionally using it. I work for Facebook. I'm on their client platform engineering team. Recently started there in July. Got a lot of other coworkers there these days that some of you might recognize the names of. It's really fun. You should come join us. I also, and this is part of all my slide decks, is that you may have seen me walking around with a LED name badge that cycles through several names. I go by lots of different handles on lots of different platforms. So on Twitter, I go by Mikey. On GitHub, I go by Pudquick. And then, yeah, on the, formerly on IRC, but now on Mac Admin Slack, I go by Frogor. And I also have a blog, seldom updated, but still interesting things there, michaellynn.github.io. All right, and with that, let's kick off the talk on here. So, pyobjc, the Frogor way. Some of you may be asking on here, like, what is pyobjc? Maybe you might not have actually ever seen it before. So pyobjc is literally the two different languages bridged together by the work of a very dedicated third party that I'll be talking about later here. The two languages are Objective-C and Python. Objective-C is a programming language that has some of the most extensive power as granted by Apple to control macOS, in large part because over 30 years ago, Steve Jobs left Apple, or was asked to leave, according to some people, in 1985. And he went to found a company called Next, which developed a line of computers running the Next Step operating system. This was a new operating system where they licensed the Objectives. They chose a new fancy language, Objective-C, to become the API for developing apps for this particular computing platform. Later, Apple ended up acquiring Next and the Next Step OS and brought Steve Jobs back onto the board in 1997. And then a year later, with Steve Jobs now as the acting CEO of Apple, Apple announced that their new OS for the Macintosh line of computers, which was developed on the shoulders of Next Step and the OpenStep development framework that came out of it. And that operating system is the one we know today as macOS or macOS 10 when it was launched. So all that work that was done has set sort of the foundation for why we have Objective-C today, basically, because of sort of that falling out and all that, everything. Not to mention a lot of the apps that you actually have on your operating system came from the NextStep operating system. Terminal app, text edit, even the chess app that all of you guys have on your computers, that one came from NextStep. It's been around that long. So Apple also has, since then, added a new language, Swift, as another alternative choice for doing API work with macOS. But Swift has only been available to us for 3 years at this point. In those 3 years, it's gone through 4 major revisions. And each time the compatibility of that language changes on which versions of macOS you can run it with, and the language itself changes, like the syntax changes drastically, like it's still, it's starting to settle down, but it's still very much in its infancy, and it doesn't have full coverage of the macOS API. There are still some APIs that are only available in Objective-C. Meanwhile, Objective-C and what effectively amounts to basically 30 years of development history for the Mac platform, there have only been 2 major version changes. It's pretty stable at this point. It's not a bad thing to spend time learning as far as programming languages go. In fact, that whole history with NextStep, Objective-C is so deeply tied into macOS and the history of macOS that you can see it in the API today, where the prefix that's on a lot of the classes, the NS, comes from that NextStep history. And so Objective-C is very deeply rooted in macOS. And so obviously it is the best language to make macOS do anything. We should all just like skip the rest of this talk and just totally spend our days staring into the bowels of Xcode. But more seriously, why should we even consider Python at this stage? And I really just want to ask you, have you ever actually looked at what Objective-C code looks like? Objective-C, part of the background of the language is that it is a superset of the C language. It is a meta language that contains another language within it. Basically, it's everything you hate about C and more. But seriously, like, I do like the C language, but neither C nor Objective-C are really, honestly, visually very friendly to beginners or people that have very limited needs from an automation standpoint. So that's where Python sort of comes into the scene here. Python, in comparison, when it was being designed, it was actually modeled on another language called ABC, which was a language specifically designed for teaching and legibility. This is what the ABC language looks like in comparison. The readability of the language is a priority, but there is a mix of like standard programming flow control, like for loops and returning values and stuff like that that you find in other languages. But it was seriously designed with new programmers in mind. And here's the equivalent Python code. It's, in a lot of ways, very similar to the roots of the language that it was modeled after. Now let's compare that to Objective-C. So, wow, a lot happened there. For starters, Objective-C is a much more verbose language. Most of the APIs, even the simple ones, end up at like a minimum of 32 to 64 characters in length to call like one thing. And that's before you start providing arguments to it. Almost to the point of being visually overwhelming. But hey, you know, if that's not working for you, you can also look at it like this. You know, we made it narrower. We just got rid of all the indentation and stuff like that. But now it's gotten kind of tall, so we can do it like this way too. So you might be saying to yourself, wow, I'm kind of having a problem reading that. All of these are valid examples of Objective-C. But the choice that the programmer makes at the time of writing the Objective-C in style drastically impacts if you were to write this code like this and then share it out to the community, how many people do you think are going to come and help you work on code that looks like this because they're sitting there just trying to visually peel it apart before they can even begin to understand what you do with it? So if we go back to Python, part of the design decisions behind it was that in order to maintain clarity, which they decided was more important than flexibility, white space wasn't just something that's nice to have, it's actually strictly required in the Python language. White space is used to indicate flow control. So if you're doing a loop in your code, the inside of that loop actually has to be indented farther in than the outside of the loop. And you end up automatically, even if you choose 2 spaces or 4 spaces or whatever, or tabs, because you're evil, it doesn't matter, you still get that indentation structure, and it visually flows a lot better. Guido van Rossum is the creator of the Python language, and when he was trying to write out his ideas about the design philosophy behind Python, he kind of ended up describing them as the idea basically being that well, it was hard to put into words, and mostly the ideas resolved around subjective concepts like elegance, simplicity, readability. It wasn't actually until Tim Peters, who was a longtime user of the language and eventual core developer, he actually captured the philosophy of Python, which became the Zen of Python, which you can actually see within Python by just typing import this. And it prints out this beautiful sort of, in a nutshell, concept of what Python is and why you should be interested in it. Some of the lines in there describe it pretty well to me and really resonate with me. Is readability counts, simple is better than complex. Those kinds of choices went into, should we, make it where a programmer can combine 5 different logic branches into a single line? No, they actually have had people suggest those kinds of things and denied those changes to the language because they want to preserve the readability aspect of it. Guido's intended target for Python was people who might need to quickly write like a shell script to do something, like maybe they just need to run a bunch of commands, but then those same people might run into like, okay, I need to remember 5 things and check for if this is in a list of 5 other things. You basically start running into data structures like lists and key value storage and things that are found in compiled programming languages. Basically, Guido wanted to give you the best of both worlds. Feel like you're kind of writing a shell script, but still have access to all those modern programming paradigms and be able to do powerful things without anything more complicated than essentially a text editor. And thus, the Python language was born. Yeah, and I mean it with text editor. You can literally open up text edit app on your computer and just make sure you switch it into plain text mode. But you can write fully functional Python code in it. You don't need to install Xcode or a compiler environment or Homebrew or any of your other stuff that is pretty common with a lot of compiled languages. You just put it in a text file and pass it to the Python interpreter and away you go. Or you can share it really easy that way too. The code you write is the code that runs. So if you put it up on GitHub and someone downloads a copy of it and they say, this code doesn't work for me, I need to make a change to it, they pop it open in their favorite text editor, make that change, hit save, run it again, it's changed. You don't have to recompile it in any way. That's part of the beauty, I think, personally, in Python. It also has an interactive mode where you can write your Python code one line at a time and see the results and play with the results as they come back and sort of explore what you're dealing with. Apple has actually shipped the Python language with macOS since macOS 10.2. macOS 10.2, sorry. So we've got this like super powerful integrated API language on one hand, Objective-C, and then on the other side, we've got this beautiful, lovely language that is also shipped with your Mac that is really geared towards learning and exploring and rapidly prototyping and sharing with others, and no need for complex tools. So that's where pyobjc comes into play. pyobjc is starting in macOS 10.5 Apple began shipping a third-party Python module. It's not actually part of the Python org Python language project. This is developed by someone else, Ronald Usorin. Apple started choosing to optionally ship this baked into all of your Macs with 10.5. It provides a bridge between the Python programming language and the ability to access the Objective-C API from within Python directly. But there is a slight cost in doing so. When you connect your lovely, pleasant-to-read Python language to the API, it unfortunately has to translate some of the verbosity that we saw earlier of Objective-C to Python in order to do so. So where in Objective-C you might have something really long like this, where, and this is sort of a contrived example, but to take a string and split it into its component words based on white space, you have lots of text there. If you wanted to do it with pyobjc-C using the same APIs, it honestly doesn't look a whole lot different. You end up substituting a method name and its arguments. You concatenate them all together and put underscores in between, and you end up with basically the same length. But then the magic of pyobjc-C kicks in. pyobjc-C actually can automatically convert back and forth between Python data types and the Objective-C data types. So when you have an NS string from Objective-C, that gets turned into a Python string, and you can do Python string operations against it. So where before we had splitting the text of the string using the components separated by characters in set and providing the white space character set, we don't need to do all that. In Python, you can just do split, and it does exactly the same thing. It splits a string based on white space. So I took a NS string object from one API and did a Python thing against it, and it just works because of the pyobjc-C bridging. Now you basically get the ability to write code in a friendly language, do logic and routines that are easy to read, and when you need to, you can dip your toes into Objective-C to do the things that deeply control a Mac that maybe you don't have a command line tool for or something along those lines. You get basically the best of both worlds, in my opinion. If you're actually at the stage where you've done a couple bash scripts or 3 or none at all, and maybe you're interested in picking up a skill like writing Python that can turn a manual process that you're doing into an automated, repeatable one, if you're maybe wondering now would be a good time to pick up learning the Python language, I can definitely recommend to you a lot of the work and writing that's been done by Greg Nagel, who's here at the conference. He's done a ton of writing and talks about Python and pyobjc-C. You can see him at his website. He's also got, when he does the talks, like there's got for the MacTech Conference 2017, he puts his materials into GitHub so you can go download like actual examples and work through stuff to learn the language. Totally recommend it. And if you want an actual like real life world example of Python and the power of pyobjc-C, you can go browsing through the code of the Monkey project itself. There are large portions of it that are written in pyobjc-C, and you can see all the cool things that you can do with it. But if you're kind of done some of these things, or you want to do more than some of these things, I offer this to you instead. I gave another talk at another conference that kind of ties into this one that's called Reverse Engineering the OS. In it, I showed how to use a lot of Apple's own command line developer tools that they provide, as well as a wonderful pay-for product called Hopper with a very lenient trial mode, like infinite trial, that I showed how to use those to dig into the operating system and find undocumented private APIs that Apple might be using to do things that an end user can click on something and they've got buttons and widgets and things that they can do something with a computer that Apple so far hasn't provided you with a command line tool equivalent or a publicly documented API to do the same thing. Using these types of tools, you can sort of peel apart the where you see some other aspect of the operating system doing it and look under the hood and see those APIs behind the scenes in many instances that pyobjc-C actually has the ability to tie into. So that's what I want to show you guys here. pyobjc, pyobjc as it ships on macOS doesn't offer connectivity to every single framework or API that Apple has available in Objective-C. It's a subset. You have the ability to import many of the common frameworks that are on the public documentation directly by name. In Objective-C, it looks like import foundation. On Python, it also looks exactly the same, import foundation. Or if you want to access something within the foundation framework, you can say from foundation import NSString NSArray. One note here, if you're doing that, there's a syntax in Python where you can just say import everything from this other thing. Please don't do this when you're doing pyobjc work. pyobjc is designed to run in a lazy evaluation mode. It will only do just enough work as necessary for the code to actually run. When you do this, you basically say, give me everything. I don't know if I need it, but I want it all. And there's a lot. And it'll actually cause your script to it beach ball for 60 seconds or something like that if you do this kind of stuff. So just be very targeted in what you're asking for. Keep it simple. But let's say you've gone digging into the OS and you want to load up one of these cool private frameworks that I've been talking about. Those don't come with header files. In some instances, it may be hard to figure out how you could tie into them with Objective-C. And the pyobjc project, as I mentioned, only supports public API frameworks. So what do? As it turns out, the macOS Objective-C API can help us out a lot here. Let me introduce you to our good friend NSBundle. NSBundle's job is to load resources and code found in arbitrary locations. Because it's part of the foundation framework, which is a public API, we can actually use that from pyobjc to then bootstrap into the private API. So the way that looks is we just say from foundation import NSBundle, and then we provided a path. And in this example, I give the server compatibility private framework. So I just say NSBundle, bundle with path, and I just give it where it is on disk. There's another one on here which is like bundle with identifier, where you can use Apple's reverse naming scheme like com.apple. There might be an identifier, but I found that some of the private frameworks that works, some of them it doesn't. Honestly, the most reliable one is just give it the path. The paths on a lot of this stuff don't shift around too often. And then you just say load it up, and you get access in Python suddenly to this private framework. Now, frameworks are a big bundle collection of related utility classes that do different kinds of things each individually. So when you want to talk to the macOS API, you don't talk to the framework as a whole, you talk to a class within the framework. In this example, I'm asking to speak to NSString or NSArray because I want to do something with a string or an array or a list of things. You would think that after we gave Python a connection to this private framework, you could get one of these private classes that are within this framework and just say from server compatibility import SVC system info because it's something I found in Hopper or something like that. Unfortunately, because we kind of brought the private framework in through the back door, you don't get a lot of that cool syntactic sugar that pyobjc provides for the public APIs. It doesn't know that there's an SVC system info class for you to import this way. But it's okay. There's another little thing that you can do to still achieve the same effect. And this goes back to the fact that we were using NSBundle. When you import a bundle using NSBundle, there is a method called class named that you can pass a string to. And you pass it to the bundle and say, give me your class named SVC system info. And the Objective-C API or macOS will just inspect the framework that it loaded, look for the class in there, and pop it right back to you. So you got to do a little extra work, but you can still get the same effect. And then once you've got that, now you can start doing the cool stuff. Now the magic really starts kicking in with pyobjc, and you can start calling stuff on it right away. And it's super cool how magical this can be. You can actually use Python itself to actually inspect one of these mystical private objects when you get it. You can just use the built-in help command on one of these things, and it'll actually dynamically inspect the class and build it's very thin, But because the Objective-C API is so verbose, most of the things describe exactly what they do, even with the private frameworks. So in here, it doesn't give a help document on here about what computer model identifier returns, but you probably could guess what it returns at this point. And so, yeah, you can then, the things that you saw in the help document, you can then just boom, connect to them, call them from Python, and suddenly you're getting private framework code running in Python with, honestly, I think it's like 4 lines of code there. It's pretty cool. And this is this right here is that the interpreter that I was talking about, where I'm literally running this dynamically by hand, typing in a thing, pressing return, seeing an instant result. So I'm inspecting it and just exploring all the things that are on here, like, ooh, what does this return? What can I do with this? And another really interesting thing about how we're loading this code is that NSBundle code lives in lots of places in macOS, not just in frameworks. They come in all sorts of shapes and sizes. For example, did you know that menu items are a code bundle and have code in there that you could attach to and load? So in this particular example, I'm connecting to the time machine menu item and getting a class called Apple Time Machine Settings out of it, and looking up the shared settings. And you can find out all cool information that your menu bar item knows all about, but TMUtil and stuff like that won't tell you anything about. And there's no public time machine API for you to go play around with and actually inspect these details because it's all private. Another example of that, as it turns out, is preference panes. Preference panes are also a code bundle. So in this particular example, we noticed that every time you open the time zone preference pane, it kicks the time daemon to dynamically do a region lookup of where in the world is the computer now if you have automatic time zone. There's not an API for this, for you to do that, but the act of opening the preference pane does it. So I went poking around in the preference pane with Hopper and found the auto time zone admin preferences on there, and found a cool thing that's on there. It says start auto time zone daemon, and you just pass a 1 to it, and it does the same thing that the preference pane does when it kicks open. So if you're doing an imaging workflow where you need to instantaneously force the laptop to discover what time zone, what part of the world that it's in, now I have a code, now I have tools that can actually do this, whereas Apple wasn't providing me with a decent automation tool of my own to do it. Now, mind you, just because you can do this kind of thing, like I hooked into a menu bar item, I hooked into a preference pane, that doesn't mean that you can like automate everything a user can do. Apple has a very well-developed security model of what they believe only certain things should be literally manually done by user, and if you've been following any of the notes about some of the latest operating systems, the list of things that they think that should be is getting longer and longer as time goes on. Apple will not let you bypass security this way. If you figure out how to do something that they disagree with, they will come back in a later operating system and lock it down. In fact, any of this private framework stuff, you have no guarantee that this is going to work to the next point release, let alone be shut down by Apple. So this is one of those things where it's sort of a dire situations type of thing, where you need to do it right now, and in the meantime, you filed a feature request for the Apple and told them that here's a gap in your operating system. I have a business need of this tool. Can you please provide me to this? And they have a thing like workarounds, and you can give them this code, and you usually get a response back along the lines of, oh my God, why are you doing that? Don't automatically assume that, cool, now I can automate every GUI that a user can do. This is like a surgical type of thing. Not everything that you load is available as a class object, like a kit of things to do. Some of them are just a standalone single function. The stuff that I've shown here was all geared towards class objects. Functions also do useful things, but to load them, you need to actually give pyobjc a little bit more than we've been doing, where you just give it the name of the thing and it gives it back. You actually have to give information to pyobjc about, okay, I know there's a function there, but how many arguments do I pass to it? What types of arguments are there? So in this particular thing, we would kind of go back to my talk about Hopper, where you can pull apart the tools or menu items or preference panes that call these functions, and the Hopper tool has like a pseudocode mode where it shows you kind of what it thinks it looks the original code looked like on how it was calling this private framework, and you can sometimes like suss out, oh, it's like 3 arguments, and the first one looks like a number, and the next one looks like a string, and the third one looks like a dictionary. And I actually wrote an article on that, which is published up on my blog, called Learn You a Better pyObjective-C Bridge Support Signature. And in it, I walk through a concrete example of basically doing that exact thing. Finding a function, figuring out the signature of the function, the arguments and whatever, and how to translate it into pyObjective-C speak to inform pyObjective-C enough that it can connect to it and do useful things with it. This example here is, it's hard to see from that far away, but I'm connecting to a bunch of 802.1x like for authenticated Wi-Fi, enterprise authenticated Wi-Fi functions in the private framework EAP 802.1x. Unlike before, where you would just provide a name and it would do all the rest of the legwork for you, it's 2 pieces of information. It's a name, and there's this little thing that's there as a second part that is it's called a signature that basically tells pyObjective-C this many arguments of this type and all that kind of stuff. And that blog post article goes into how to figure out what those look like, how to build them yourself. Another side note on here, when you're diving into the weeds on this kind of stuff, try Google searching every single thing that you find. So in this particular instance with the 802.1x, these function names, when I Google searched it, I got hits on opensource.apple.com. It's a private framework, but they actually published actual code that touches this. So instead of needing to use Hopper or anything like that, you can go straight to how Apple actually, the source code of how Apple is actually using these functions, and just cut straight to the chase. You don't have to do any guesswork on it. This one was allowed me to do things like dynamically inspect your 802.1x connection that you currently have and get the exact certificate identity that the user has connected with. So you have 3 choices. I know which one you chose because the preference pane says the name of the certificate that you chose up there. This allowed me via Python to inspect your certificate, get all the details about the certificate, like when it expires, all that kind of stuff, and certificate information of the Radius server that you were talking to. So I got a lot of cool diagnostic information that I could roll out to the fleet and get results back in an automated fashion via these private frameworks that Apple actually accidentally sort of published all the details about. Yeah, basically like in situations like this, sometimes you can luck out totally and get a whole lot of information for honestly not a lot of effort. Now, remember when I said pyObjective-C didn't ship with all of the public APIs available? Part of the reason of that is that the project is constantly being improved and more public APIs are being added with each successive release of it. But unfortunately, Apple is shipping an older version of pyObjective-C with macOS. The version that they're currently shipping right now is 2.51, even on macOS 10.13. It's up to 4.0 now. There's like so much stuff. And you can open up issues against it and say, hey, I tried to open up this public API and it's not defined in here. Could you look at it and see if you could implement it? And Ronald is awesome. He's a beast on this stuff. And he's got automated testing and make sure it works on all these different macOS versions. So it's like, okay, cool. pyObjective-C 4.0 has more capabilities than the one that's built into all of my Macs. Well, as it turns out, Ronald did another cool thing here. He made it where the pyObjective-C module, the publicly published one on the Python package index, is available in what's called a wheel file. If you're not familiar with Python at all, you can download modules written by other people, and they come in all these different formats. And what's cool about wheel files is that they are pre-compiled. They don't need you to have a compiler environment, command line tools, Xcode, anything like that. You just need an internet connection, and you can just run like pip install and give it the name of the module, and it'll pull the thing down and install it on the machine, and you suddenly, boom, have a fully updated version of pyobjc on your device. It's super cool. And I really recommend exploring the differences if you get into pyobjc between what ships on your Mac and what's available on the latest version. But I will give a disclaimer on that. A lot of community tools are geared around pyobjc that ships with your Mac. If you upgrade the pyobjc that's available on the Mac and install it in the system Python context, you may actually break a lot of community tools because there are some syntax changes between the pyobjc version. So I definitely recommend it from a exploring, learning standpoint, but if you are interested in deploying it out to your entire fleet and you're already using a lot of maybe community-built tools that are Python-based, definitely test out compatibility, make sure you don't blow your stuff up. All that to be said, I hope that some of the things that I've shown you in this talk, if not directly applicable to where you are right now in your skills, hopefully they open your eyes to the possibilities that pyobjc on macOS provides. I am a fervent believer in and proponent of and encourage the community that the ability to literally share a text file and read, inspect what it does, make changes to it. I've got one that reorders Wi-Fi SSIDs on your device. There's still no command line tool or profile for this. There's multiple radars open with Apple right now. Can you provide us a management where we can lower the priority order of our guest Wi-Fi SSID below our corporate one because someone dragged them into the wrong order or joined them in the wrong order. The ability to give that out to other people, and they can literally just open it in a text file and change the SSID that's in there and then run it on all their Macs, via Jamf. They can just paste the script in or Monkey or whatever you want. The ability to just give people a text file that they can edit, make slight changes to, and immediately use, I think it's so valuable. And there's a lot of power there, and it's a really, Python itself is a really enjoyable language. Any Mac management tool that you can basically paste a script into, you can literally take advantage of this stuff out of the box and just vastly increase the capabilities of what you can do for your fleet. All that to be said, I hope you join me on this fun journey diversion. I hang out on the Python channel on the MacAdmin Slack, macadmins.org. Feel free to drop in, ask questions anytime. Thank you.
I am 1,000% sure we have a few minutes for questions, and I'm 1,000% sure there are some questions. Here we are.
I'm going to ask a question that's going to hopefully lead to you giving some advice, but what would you say is a good approach if you wanted to try this out? Like, what is a neat, self-contained example you could give of if you wanted to try this out that might actually be, of some use? You showed the time machine thing, but is there anything that, you would recommend just to poke at and get some quick results?
To poke at and get some quick results. Are you talking about like an existing pyobjc project, I'm playing around with it, or just going to try and touch pyobjc? Honestly, I would recommend in this particular instance that you check out some of the demo projects for pyobjc that Greg has on his repo. He starts kind of at the beginning, like super basic, and then gets into things like popping a notification up on your screen and stuff like that, which is super cool the first time that you're like, I made that thing pop up on the screen from Python. I definitely recommend checking out Greg Neagle's GitHub repo and looking at some of his talk samples that he's got in there. This is probably some of the best fun to play with APIs that you can go poking around with.
Cool. Other questions?
Mike, do you do any GUI integration and development, and how do you go about doing that with pyobjc?
So, funny thing you mentioned that. There is, at another conference, I did this thing called Nibbler. It It was a Hack Week project initially. And I need to get pictures up on here of using it. Here's an example of it. Setup example. No, that's not really good. So the Hack Week project that I did, oh, you can't even see that. I'm sorry. Nibbler under my PudQuick. It's one of my few repos. Most of my code is in gists. Enough people bugged me about it that I finally got it up in a repo. So as it says, Python pyobjc utility for macOS for displaying dialogues using nib files. So there's this project that maybe some of you have heard of called Cocoa Dialogues, which is a cool project, awesome project. It's a compiled executable that you can ship to your devices and pass it a ton of arguments or various other inputs, and it will custom build dialogues for you and all that kind of stuff. And I was thinking about like the NS bundle stuff where I could load all these cool things and whatever, and I was wondering, could I load a dialogue from pyobjc, like from just a script? And how would I build that dialogue? I really like the dialogue builder that's in Xcode. I like Interface Builder a lot. It's just drag and drop. You just drag buttons in and put your text in there and hit save, and I've made a dialogue. So I hacked together this project called Nibbler that you can literally go into Xcode, drag and drop together a dialogue that you want to make, and then with a few lines of Python, point to that nib file that comes out the other side and connect it to Python functions. And then when you run the Python script, the dialog pops up, end users get buttons that they can click on, very familiar interfaces, totally customizable. I have an example in here. It's too bad I don't have audio. I could have shown my vote for frogor video when I made this thing for the Hack Week project. I was inspired by an example that was done with Swift Playgrounds where they were showing how easy it was to build these dialogues, whatever. I'm like, I can do that with this. And I threw in like a map and all these crazy things, and it works because you just drag and drop those elements in. And I mean, connecting to a map and getting useful information out of Python is a lot harder. But yeah, I have done some like GUI stuff with it. This is one way to approach that. Another way to look at it is if you look at the Monkey project itself. The Managed Software Center is written in Python, but it is a full GUI app that presents to the end user. It is a completely different style, though. That's the type of thing that you actually go into Xcode but write Python while you're in Xcode. So there's a couple different ways to approach doing GUI elements, but you can do it with something literally as simple as you download this Nibbler py file and put it in the same directory as your Python script, and you just import Nibbler, aim it at the nib file, and boop, pop dialogues and interact with the end user till the end of the days. Yeah.
Questions? There we go.
From some of your examples, correct me if I'm wrong, it looks like you're using Python 3.
Nope, Python
no, it's
2.
Python 2. What is the compatibility with Python 3?
pyobjc has full compatibility with Python 3. The version of pyobjc that ships on macOS, I can't necessarily say that it does. I don't know the compatibility history when Ronald added Python 3 support. The reason that I target Python 2, though, is because that's what Apple ships with the devices. All the Python code that I was showing works out of the box on a brand new Mac. You don't have to install anything. You just copy the text file to it and execute it, or use your administration tool of flavor of choice and tell it to run the text instead. So yeah, it is Python 3 compatible. I'm just not sure which version of pyobjc is Python 3 compatible. But he's got automated testing stuff in place, and he tested against like half a dozen different versions of Python 2 and Python 3. Python 3 support is definitely one of the goals of the project. So, thank you.
So I actually get to ask some questions every now and then, I guess. So I have some follow-on questions from two of the questions that were asked, I think. One, speaking of Python versions, you know, in the beginning of the talk, you mentioned Swift is 3 years old and it's been through 4 major revisions. Mm-hmm. And I agree, that's been a huge problem for Swift. But at the same time, Python 3 was introduced
over a decade ago.
10 years ago,
yeah.
And it just is not getting any traction.
Yeah.
So do you think that signals anything for the future of Python?
That's a really good question. I think the momentum in the recent time here has actually shifted a little bit. A lot of, so surprisingly, or maybe not surprisingly, maybe some of you are familiar with this, one of the larger groups of people that actually make use of Python are like bioinformatics, like natural sciences and stuff like that. They do a lot of data analysis. There's like SciPy and NumPy and all these like number crunching Python libraries that are super, super, like behind the scenes, it's all compiled code, but it presents a Python way of accessing it, which is super friendly to researchers. And so it's really caught fire, and a lot of work is being done with it. Some of those, just literally, even last week, I think it was NumPy or one of them, actually signaled end-of-life support for Python 2, and they're forcing the community to Python 3. And I'm seeing that shift happening for a lot of those specific science-related frameworks and stuff like that, that I think it's going to finally, maybe, hopefully, kick the community as a whole over to 3. Now, whether that will make Apple ship 3 on a Mac, couldn't tell you. Apple's tendency as of late is to strip out anything that's not Apple from their computers. I think the only reason Python 2 has lasted on the Mac as long as it has is probably A, there's a contingent of Apple employees that just love having Python on their devices, but B, there are some things, strangely, that ship with the OS that actually, just a few things that rely on Python. The X attribute command that ships with all your Macs, if you've ever gone to look at the Apple quarantine extended attributes on a file or something like that, that's all written in Python. So in order to rip it out, they would have to replace that or something like that. So, but I think they would definitely, Apple themselves would be more likely to rip it out than they would put 3 in. But it could surprise me. Versioning you were talking about on there. Apple has, it's like the hell's frozen over or something. They just finally relinked Python in 10.13 against LibreSSL.
Right.
So it suddenly, Python on macOS has been sort of a security bastard, basically, in that it hasn't had support for modern web protocols. You couldn't even talk to Apple's own websites if you're trying to do things like look up serial number information about your Mac with some of the URLs that are out there, because Apple switched over to only speaking TLS 1.2. The Python that they ship on their Mac, though, was linked against OpenSSL 0.98 and only supported like TLS 1. In 10.13, they bumped it up. It's LibreSSL. So like they're not ripping it out. They are actually updating it. They didn't go to 3, but so I could be wrong. Maybe they'll ship 3. But the community as a whole, I think eventually 3 will get there. But it's been a long road. It's been a super long road. And I will admit, I still write everything in 2, but I'm targeting like Mac devices, and so it's more useful.
And then my other question is around, you know, in years past, like Python has caught on because I think people in the Mac community really liked Python, and we looked at admins that were maybe just starting out, and the advice we would give them is like, look, if you're writing this bash script and it has more than X lines or X number of functions, like really just make it a real thing and do it in Python.
Yeah, yeah.
But my question is, do you see a threshold where that breaks down and instead of writing some enormous thing in pyobjc, it's like, well, look, just do this in Objective-C?
So, yeah, there's definitely that. Like the Nibbler thing that I showed on there, it was literally a hack project. It's designed to pop a simple dialogue and stuff like that. But in some situations, I've seen people develop very complicated workflows with it and run into weird edge cases with it. And it's like, it's not an application. It's not. It's just enough code to do the trick, but it's not. It doesn't get all the benefits of a full application. Like for instance, real compiled like GUI apps and stuff like that. They have a run loop. They can respond to events from the system. There's an API that the core location services, where if it's location services is enabled, you can actually do some estimation of GPS coordinates for your devices. So you can kind of do like LoJack in Python, basically, if you really wanted to. But in order to even get that working, you have to implement an NS run loop and kick it every couple of seconds because it's event-based. And you start getting like hacks on top of hacks on top of hacks that at a certain point, yeah, you need to look at it and go, this is a worthwhile project. We should just do it in an actual compiled language and turn it into the real deal. And some things you would never want to do in Python. If you're writing an authorization plugin, I don't even want to begin to imagine how you would do that in Python, and nobody ever should attempt to do it. There are just certain classes of things you should definitely go all the way and go to like Swift or Objective-C or something like that, or Go or something. Yeah.
Okay, thank you. Quick follow-up to that. And run the microphone over there.
So I've actually been thinking that this week with the changes that are coming with 13.2 and all this code signing and user approved stuff. I've been kind of wondering if Python would go away and we'd have to turn Monkey into a Swift project, and we'd have to all of these tools that we're doing to get around the things that they aren't doing for us, if we're going to have to actually start compiling those.
So,
It's a speculation anyway.
there are some architectural changes that happen with Python, for instance, and we've already had to do some hacks to work around them in the Monkey project. Like, for instance, Monkey, even though we don't recommend it, you can still run a Monkey repo based on HTTP, an unsecured Monkey repo. But with the advent of, what was the name of the transport? The TLS secure transport stuff. Apple basically made it that by default, if you used their APIs and you linked against like 10, 12 or later when you built your app, that it would only ever do secure connections. It would never actually, the APIs wouldn't even work with unsecured connections. And the problem is the way that you declare I need to work with unsecured connections is in the application bundle itself, which there is a python.app that is on your machine. There is a bundle that lives, but it's under a SIP protected location. And it doesn't have that stuff in there saying, I need to be able to make unsecured connections. So we do a hack to actually like post-inject that configuration into the Monkey project. And yeah, there could absolutely be more of that kind of thing down the road where it becomes more and more increasingly difficult to do these kinds of tricks, basically. And yeah, you might have to cut over all the way to just cut the line and go to a straight compiled app and follow Apple's guidelines and stuff on there. But right now, that's not the case. You can still do a lot of stuff. But yeah, the way things are going, changes are happening fast. There could be that day where I recommend learning programming no matter what the language. It is such an awesome tool that basically expands your ability to be like 100 of you or 1,000 of you or whatever. I don't care what language you learn. I just recommend you pick at least one, maybe more. And I don't think you will go wrong in doing so, no matter what language you choose. Just don't do Bash.
Awesome. And on that positive note, one more round of applause for Michael Lynn.